Hey folks, welcome to another set of Intro Chem video notes. To start off our second unit, we're going to learn about ionic bonding and how to name ionic compounds. The official standard that we're covering is listed here. Throughout this unit, my goal is that you'll be able to use the periodic table as a model to predict the relative properties of elements based on the patterns of electrons in their outermost energy level of atoms. Some words you'll need to know for this lesson include ion, cation, anion, ionic bond, metal, and nonmetal. Let's get started. As you should know by now, valence electrons are the electrons in the highest principal energy level, those on the outer shell of electrons in an atom. What you may not know yet is what's really important about these valence electrons is that they're the only electrons that participate in chemical bonding. The octet rule says that every atom wants to have a full octet, or 8 valence electrons, in its outermost shell. This is true for almost all elements, except for hydrogen, helium, lithium, and beryllium. Those follow the duet rule and only want 2 valence electrons, so they look like helium. Anyway, all elements want to look like a noble gas. In order to get that full valence shell, atoms will have to lose, gain, or share electrons to get there. In today's lesson, we're focused on only the losing and gaining of electrons, not the sharing. When an atom loses an electron, it now has more protons than electrons, so it has a positive charge. We call these cations. An anion is an ion formed when an atom gains an electron. These have a negative charge, because they have more electrons than protons. A good way to remember these two names is that cats have paws, so they are positive. And anion sounds like onion, and onions are negative because they make you cry. So here we are, ionic bonding. Any chemical bond is just a force that holds 2 atoms together in a molecule or compound. When one atom loses an electron, it gives it away to another atom which gains it. This creates a positive and negative ion. Those oppositely charged ions attract to each other like magnets. This magnetic attraction, or electrostatic attraction, is called an ionic bond. Substances that are made up of particles held together with ionic bonds are called ionic compounds. An important thing to note is that atoms don't just gain or lose electrons willy-nilly. These electrons don't just go away or come from nowhere. They get transferred from one atom to another. In fact, these electrons get transferred from a metal to a nonmetal. Metals give up their valence electrons and become cations. Nonmetals gain those valence electrons and become anions. Drawing Lewis dot structures for ionic compounds is super easy. Start off with drawing the normal Lewis symbols for the elements in question. Then move electrons from the metal atom to the nonmetal as needed. Your goal is to remove all valence electrons from the metal atoms and find a place for those electrons on the nonmetal atoms, filling all empty spaces on those nonmetal atoms. Every time you remove an electron from an atom, it adds a positive charge to it. Every time you add an electron to an atom, it adds a negative charge to it. For example, here's lithium chloride. We start out with the lithium and chlorine atom. Then we move lithium's 1 valence electron to chlorine. Chlorine has exactly 1 space to be filled, so when we put that electron over there on the chlorine now has 8 and it's all done. In the final step, you redraw your symbols to show lithium without any valence electrons, and it has a 1 positive charge, and the chlorine with 8 electrons and a 1 negative charge. You sometimes will have to add more than one of each of these atoms in order to get all electron spaces filled appropriately. For example, sodium nitride will take 3 sodiums to fill up the 3 empty spaces on the nitrogen atom. This gives us 3 sodium 1 plus ions and 1 3 negative nitride ion. Naming ionic compounds is super easy. You just write the cation element name followed by the anion element name, with the anion's ending, or last syllable usually, changed to an ide, I-D-E. For example, lithium and chlorine together make lithium chloride. There's only one weird rule for naming ionic compounds. For any element that can form multiple ionic charges, we have to specify which charge it has in its name. To do this, you simply use Roman numerals. So, all compounds with a transition metal, except for nickel, zinc, scandium, or silver, will have a Roman numeral in its compound name. For example, if a compound is made up of lead 2+ and a 2- sulfide ion, we wouldn't just call it lead sulfide, but we'd call it lead 2 sulfide. That 2 just tells us that the lead has a 2+ charge. If you're given the name and have to write the formula, we have to do a little bit of work. Since ionic compounds don't exist as discrete molecular units, but as large, highly ordered conglomerations of ions, which are called crystalline lattice structures, we just have to write the simplest whole number ratio of those ions in that structure. To do this, use the name to figure out which ions are present, write the ion symbols down with their charges. Don't forget, if it has a Roman numeral, the positive charge is just whatever the Roman numeral is. Ionic compounds have no overall charge, so your goal is to get the same amount of positive charges as negative charges in your compound. The easiest way to do this is to cross-multiply your charges and write them down as subscripts on the other atom, then reduce them to the simplest whole number ratio. So say we're given the name lithium oxide. Lithium always forms an ion with a 1+ charge, and oxygen always forms an ion with a 2- charge. So you take the 1 from lithium's 1+ and make it a subscript on the oxygen. You take the 2 from the oxygen 2- and make the 2 a subscript on lithium. That gives us Li2O. We can't simplify that anymore. 2 and 1 are the simplest whole number ratio, so that's just the formula, Li2O. You don't write charges in the compound formulas, just the element symbols and their subscripts. Last but not least, we need to know how to find the charges for different elements. That's easy. You have a periodic table of ions for that. For the representative elements, the metal ions will have the same charge as the group number they're in. Group 1A forms a 1+ charge, 2A a 2+ charge, and 3A a 3+ charge. For nonmetals, it's based off of how many more electrons it needs to add to look like a noble gas. So group 7A, the halogens, who's just one valence electron away from a noble gas configuration, will have a -1 charge. The oxygen family gains 2 electrons, so they get a -2 charge, and the nitrogen family gains 3 electrons, so they get a -3 charge. For all others, just look at your periodic table of ions. Or if it forms multiple charges, you'll have to look at the Roman numeral in the name. Well, that's all for today, folks. As always, if you have any questions, ask.